Well, let's try to find another McLaurin series. So let's try to find the McLaurin series of the function f of x equals sine x, and also let's try to find the radius of convergence of this series. Well, we have the formula. We need to calculate the derivatives of f of x and evaluate them at 0. So of course the derivatives are either plus or minus sine or cosine. We have f of x equals sine of x, its derivative is cosine, the derivative of that is minus sine, the derivative of that is minus cosine, and the derivative of that is sine of x, and the cycle continues over every 4 derivatives. Plugging in x equals 0, we get f of 0 is 0, the first derivative of 0 is 1, the second derivative at 0 is 0, the third derivative at 0 is minus 1, the fourth derivative is 0. So we see that the nth derivative is going to be 0 for all n values which are even, and it's going to alternate between plus or minus 1 for n odd. So the Maclaurin series for sine x is going to be f of 0 plus f prime of 0 over 1 factorial times x, plus the second derivative at 0 over 2 factorial times x squared, etc., etc. And here the even powers of x are going to disappear, and our series is going to become x over 1 factorial minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial. And we can compactify this in our summation notation by writing these odd powers of n as 2n plus 1, and they have coefficient minus 1 to the n because they are alternating between plus and minus 1. So the nth term of this series is given by minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, and we're summing from n equals 0 to infinity. Now, how do I check the radius of convergence of this series? Well, of course, I use the ratio test, and taking the limit as n goes to infinity of the n plus 1th term over the nth term, assuming x is fixed, I get the limit as n goes to infinity of the absolute value of x squared over 2n plus 3 times 2n plus 2. The x is fixed, the denominator is increasing without bound, so this limit is 0 no matter what value x takes. So therefore, this series converges for all values of x. I do not know that this series sums to sine x for every value of x, but in fact it does, and we'll see that later.